All right, 2021 free response AB number 2. This is calculator active. Good for us because these formulas are going to be, or these functions rather, going to be a little tricky. Particle P is moving along the x-axis. The velocity of the particle is given. Notice they gave you velocity, not position. And this works for the interval from 0 to pi. Then they tell you the starting point of it. So at t equals 0, particle P is at x equals 5. And then we also have a second particle, particle Q. You also have the velocity of that one. Sometimes they'll give you velocity for both. Sometimes they'll give you velocity for one and position for the other. So read very carefully. The velocity of particle Q at time t is given by this crazy function, same interval. And then they tell you the starting position for the particle, so at time t equals 0. So then part A, find the positions of particle P and Q at time t equals 1, so let's jump in. I've already typed these into my calculator, and I'll let particle P be y1, particle Q be y2. There, took me way too long to say that. So we're going to start at a specific place. So for particle P, let's do that one first, of course. For particle P, when time is equal to 0, it starts at x equals 5. So we're going to just start at 5. So we start at position 5 on the x-axis, and we're going to move. Well, how far are we moving? Well, this is our displacement. V sub p of t, and then dt. That's it. It's really that simple, and we're going to just crank out an answer from there. So this is going to be particle P, and then we're going to do the same thing for Q. So here's P, and then there's going to be Q. And for Q, notice that we're going to start at 10. So I'll go ahead and write everything, and then we'll go from there. So 10 plus 0 to 1 of v sub q of t dt, and that's equal to something. We'll go ahead and type those in the calculator very quickly. Here we go. 5 plus math 9, 0 to 1, alpha trace, dx. These are typed in using x. So this is the position of particle P, and this is the position of particle Q. That's it. So here's P, 5.371. And by the way, if this would have truly rounded to 370, you'd need to put the 0. If the decimal continues after the third decimal place, put the 0. So 8.564, or in those circumstances, you would. That's what we have. All right, that's it. Let's grade this thing, and I'm glancing over at the side at the scoring guidelines. So for this, you're going to get 3 points for part A, and what you're going to get points for would be a definite integral. So either one of these right here, either one of these two things would give you a point, and then you'll get a point for this one, and then you'll get a point for this one. Okay, part B. This is where things get a little bit tricky, so let's read carefully. Are particles P and Q moving toward each other or away from each other at t equals 1? Explain your reasoning. Okay, so let's think about it logically. Here's P, here's Q. P, Q, they will be moving toward each other if P is to the left of Q, and P is traveling to the right while Q is traveling to the left. They'll be moving away from each other if P is to the left of Q, and pause here. P is to the left of Q. They're on a number line, right? They're basically on an x-axis. Just some numerical way of us quantifying where they are, where their location is. So P is to the left of Q. That's going to come in really handy. So P is to the left of Q. They will be moving away from each other if P has a negative velocity and Q has a positive velocity. So here's the deal. We need to find our velocities. I'm waving the ink pens. We need to find our velocities at t equals 1. So let's do that. That's going to be important. So the velocity of particle P at 1 is something. The velocity of particle Q at 1 is also something. And I really don't care what that something is. I do care about the signs, though. So here goes. I'm going to go to the table, actually, and I'm just going to delete the stuff that I had, which was from something else. And if I just have this set to where it is on ask, second and table set, independent is set to ask, then I can just press 1 and crank out answers, and that's really all I need right there. So here's particle P's velocity at t equals 1, particle Q's velocity. So 0.8415, I'll call it 8.2, and that's negative 1. So I really don't care, again, what the numbers are. I care that this is positive and that this is negative. Let's make a sentence. So we have determined a couple things. We have determined that P is to the left of Q. Again, here's P, here's Q, P, Q, And we also know that P is moving to the right, Q is moving to the left, therefore they're going toward one another. Let's put that into words. P is to the left of Q and is moving to the right. It's always a good idea to explain how you know what you know. How do I know it's moving to the right? Here's why. Because the velocity of particle P at 1 is positive. Okay, P is to the left of Q, which means Q is to the right of P. You can say that. It's a little redundant. We've already sort of said that in this statement. Q is moving to the left. Tell how you know that. Here's how you know. Because the velocity at 1 is negative. All right, what conclusion have we reached? Because here's P, here's Q, positive velocity, negative velocity. They're going to run into each other, or they're traveling in the same direction. So they are moving toward each other. Therefore, P and Q are moving toward one another, each other, one another. We're not picky about that level of grammar in this type of thing. All right, let's grade this thing. For part B, you will get a point for the actual explanation. And if you look at the scoring guidelines, you'll see something along those lines. But you will get another point for the direction of motion for one particle. Here we go. The direction of motion for one particle, and if you're looking at this over here, it didn't print right. I have equal signs and greater thans all out of place. But the direction of motion for one particle, so either particle apparently, I would get some point for saying Q is moving to the right, for example. Oops, not Q is moving to the right. P is moving to the right. P is to the left of Q and is moving to the right. Subject to that sentence is P, so therefore it works. All right, let's go to part C. Find the acceleration of the particle Q at time t equals 1. Okay, I want the acceleration. Let's just stop right there. Don't even keep reading. Let's go do that. But before we move on to part D, make sure you've answered the rest of it. It's going to come in handy. So part C is asking for the acceleration, and the acceleration is the derivative of velocity. In case no one ever tells you, and this is for particle Q. So the derivative of velocity at 1, because that's what they're asking, and I'm going to define that to be the acceleration at 1, okay? Don't just start with this and be like, oh, the acceleration is, no. They need to know, they being the people that grade your paper, they need to know that you know that the derivative of velocity is acceleration. So let's do this with a calculator, and math 8 in deriv. The derivative with respect to x, actually, not t, based on what we have in the calculator. And this is going to be alpha trace y2, because we're dealing with the Q particle, and this is going to happen at x equals 1. There we go. 1.027. 1.027. 0.027. Okay, here's what I care about. That's positive. I'm just saying, I'm throwing that out there. They asked for this, I went ahead and did that. You can put that or not. I almost whited it out, but yeah, let's white it out. Put that or not, doesn't matter. Because I've read ahead and I know what it's asking. Is the speed of particle Q increasing or decreasing at time t equals 1? All right, here's how you know. Are the velocity and acceleration at time t equals 1, this positive, let me rephrase that. Are they the same sign or different signs? Velocity is negative, acceleration is positive. Different signs. Okay. Particle Q. Particle Q is slowing down. I hesitated because they did not say slowing down. They said, is the speed decreasing? I'm going to get really specific here. Okay, this is fine, I believe. But I want to word it the way they worded it. The more I teach this and the more I try to train people in this, the more I realize I want to word it to answer it the way they asked it. So probably not wrong, but I'm going to say this. Speed is decreasing. Because we can run into situations where we have used some, I almost said slang, that's not slang, but some grammatically correct thing that really misses the mathematical point, okay? Slowing down means the speed is decreasing, but in other contexts, other substitutions for phrases may not work. So I want to get in the habit of saying what they said. Speed is decreasing. Okay, just a good habit to have. Speed is decreasing at t equals 1. How do you know? Because the velocity at 1 and the acceleration at 1, I can use that now, we've defined it to be the derivative of velocity, have different signs. All right, let's grade it, see how we did. I got 100, yay! I get a point for this, that whole thing. They just need to know that you did the derivative of velocity and got that number. And they also wanted, well, basically this. So they needed to know that you said the speed is decreasing and why, and this is why. Okay, we have enough room for part D, which is super short. Here goes. Find the total distance traveled by particle P over the time interval from 0 to pi. So here goes, let's do this. The integral from 0 to pi, the velocity of particle P is going to go here. By the way, this is incorrect. Let's stare at it for a second. I did this on purpose. This will tell me the antiderivative of the velocity, which is going to be the displacement. That is not the total distance traveled. They are asking for the total, there it is, total distance traveled. This will do it. So let's do it. The integral, math 9, from 0 to pi of absolute value. Press math, go over to number, pick abs. Particle P, so it's y1. That's wrong. I left my x off here and I put an extra one there. Whoops. And we wait. We'll just sit here. How about that? There it is. 1.931. Let's grade this one too. 2 points. We're going to get a point for the definite integral. It better include absolute value and a point for the answer.